Okay, so now let's go into this question. And what we're gonna do is we're going to try out the stuff by brute force a little bit and then see how our techniques can actually be useful. All right, so if we were to compare this, and I am just gonna put out 19 over 15 because I feel like it. If we were to compare the two fractions with the process that we followed, the common denominator one, we would have to do 15 times 15 divided by 11 times 15, then versus 19 times 11 over 11 times 15. Again, that's so much calculation, so it's just painful. And you're going to have to do that for the other 2 times more because you're going to have to compare 15 over 11, 17 over 13, and the other. So now let's look into a technique that we found. It was x over y is greater than 1. That's true here for all the fractions. And z is greater than 0. Then we have that x over y is greater than x plus z over y plus z. What this means is that if we plug in the appropriate values, 15 over 11 is actually, if we have 17 over 13, it's 15 plus 2 over 11 plus 2. So by this rule, 15 over 11 would be greater. And then 15 over 11 is also greater than 15 over 4 plus 11 over 11 plus 4. Sorry, 15 plus 4 and 11 plus 4, which is equal to 19 over 15. And this is equal to 17 over 13. And if we compared 17 over 13, we'd also get the same idea because it's 17 plus 2 over 13 plus 2 is equal to 19 over 15. So very quickly we get that 15 over 11 is the greatest, then we have 17 over 13, and then we have 19 over 15 over here, and that would be E. So with their formula, it's so much easier because if you look at it, you would have to multiply this entire thing out, and likely you might go wrong in some places, and then you will mess up your entire order, which would result in the wrong answer. Or it would just take an essentially long time to do it. And in AMC8, time is not your friend. You have very less time to do all the problems. There's 25 questions in 40 minutes. All right, let's go into ratios and proportions. In essence, ratio of two numbers is like A over B. There, it's like a fraction. You can also say it as A colon B or A to B. So that's that. And two ratios, A to B, and C to D are considered proportional if the fractions represented this way are equivalent. And what this means is that I guess both their simplest forms are the same. And for a matter of fact, these are actually the same. They're proportionate. So let's do like a quick problem with proportions. So an amusement park has a collection of scale models with a ratio 1 to 20 of buildings and other sets from around the country. So what this means is if there's a building in the amusement park and it has a height, or it has a height h, then the actual building, which is like huge, has a height of 20h. That's what it means. The height of the United States Capitol building is 289 feet. So the actual United States building is 289 feet. They're asking for the height of its replica. So I set up something on the left over here. And what this basically means is I'm saying, all right, 20 over 1 is proportional to 289 over x. They're both proportional. So we need to find a value of x for that. And what we're going to do is we're going to do something called cross multiplication, which I will show you shortly. So what you do in cross multiplication is when you have an equal to sign and two fractions on either side, you multiply this one over here and you multiply this one, and it creates an x across. So that's why it's called cross multiplication. And so you get 20x is equal to 289. Then you can divide both sides by 20. You get 289 over 20. And in essence, that is about 14 point something. So and it's like to the left side. I think it's like 14.4. So your answer will be 14. So that's the basics of ratios and proportions. Please note this like cross multiplication thing because it's very, very useful. All you're basically doing is taking 20 over 1, you're dividing by 289 over x, and this is equal to 1, and then you're flipping it, right? Because that's how division works with fractions. And if you notice, you get 20x over 289, and then if you just multiply that back, 289 on both sides, and you get 20x is equal to 289. So it's basically that. It's division, but in a quicker way. Okay, here's an example. If the degree measures of the angles of a triangle are in the ratio 3 to 3 to 4, what is the degree measure of the largest angle of the triangle? I'm going to leave this off with a note saying that the sum of the angles in a triangle is 180 degrees. So that will be the property that you use, and along with ratios and proportions, we can make this question work.